I'm going to be going through some single replacement reactions and their corresponding word equation. So the first thing for a single replacement reaction is to look at what the individual element is, because that'll tell you what is trying to be replaced. So if I look here, we see that we have silver. And so silver, if we remember to look up its charge, would find that it's a +1, which means it would want to replace sodium, which is also the positive charge from the compound. And we would also know that sodium is a +1 charge. Now, for single replacement reactions, we need to first make sure that this reaction would even go forward. And the only way it's going to proceed is if silver is more reactive than sodium and can steal the hydroxide from it to bond with itself instead of bonding with sodium. And so we'll look at our reactivity series, which is going to be on the handout I'll give you. But we'll see here that sodium compared to silver is more reactive. And so the more reactive thing will always want to be in the compound. And since the more reactive thing is already in the compound, this reaction will not even happen. So we would say no. If the reaction doesn't happen, you don't have to do anything. You can simply put NR for no reaction. We can mix these things together. We would not see any evidence of a chemical change. So we can also put that in the word equation box. Nothing would proceed here. Okay, going to reaction number 2. Now this is given to us in a word equation. So the first thing I'm going to do is translate the words into a formula. And so this is copper, and it's telling me the charge is 2. And then it's chloride. So I know that chloride should have a -1 charge. So that would be CuCl2 if I make that formula. And then we're adding fluorine. Now fluorine is one of our Hoberfinkel elements, which means it'll need a subscript of 2 because it is alone in this case. The 2 on this chlorine is not because of Hoberfinkel, it's because of the 2 on the copper. But when fluorine is alone, that's when we're having that 2 there, just because it won't be by itself like we saw with silver. The next thing to do is to decide what is trying to be replaced here. And so if we look at our individual element, which is the fluorine, we know that that would have a negative charge, a -1 charge specifically, which means based on these two things, it would try to replace the chlorine in the compound. For the reactivity of our halogens, we're going to use our reactivity trend from first semester. So we would expect that fluorine is going to be more reactive than chlorine. So this reaction will go forward. And so on the other side of the arrow, I'm going to put chlorine by itself because fluorine is going to kick it out. And then I want to bond fluorine and copper together. Now I already know that this is copper 2. And as I said before, fluorine has a -1 charge. So we're going to find that this formula between copper and fluorine is going to look basically the same as this one because they have the same switching of charges. And then the last thing to do here is realize that chlorine is now by itself. And because it's part of those Hoberfinkel molecules, we'll want to put a 2 with it. Our products, therefore, this reaction will happen. Our products are going to be copper 2 fluoride plus chlorine. Doesn't matter the order you write things as long as you're writing the correct things together. The last step is going to be to balance. If we look, we'll find that this is already balanced. We have 1 copper on the left side of the arrow, 1 copper on the right side, 2 chlorines on the left, 2 chlorines on the right, 2 fluorines on the left, 2 fluorines on the right. So we don't need to add any coefficients to this reaction. So this is good. If you want to add coefficients to keep kind of a count of them, we'll put a 1 coefficient for all of them. Okay, moving on to reaction number 3. So we're starting with the word equation again, and we're going to need to convert that into the symbol equation. Because we haven't talked about acid naming, I've already given you how sulfuric acid would look. And then the thing here is magnesium. It is by itself, so we just put the symbol. It is not part of Hoberfinkel, so it is just Mg. I don't put like a little tiny 2 with it. And then the next step is to see, is this going to happen? If I look, magnesium is a +2 charge. Hydrogen, in this case, because it's coming first, is a -1, and then sulfate is a -2. This is important to know because anytime a reaction does go forward, we need to remake formulas based on their charges. So looking here, we would see magnesium compared to hydrogen. And magnesium is more reactive, and since currently hydrogen is in the compound, that means magnesium will kick it out because the more reactive thing should always end up in the compound. So this reaction will happen. Hydrogen gets kicked out. Magnesium now will go with sulfate. Magnesium is +2. Sulfate is a -2. So we know that those charges will reduce, and that will give us MgSO4. The last thing to do is look over at our thing by itself and just see if it's part of Hoberfinkel. In this case, hydrogen is part of Hoberfinkel, so we'll put a 2 there. And then very final step, balance. 1 magnesium, 1 magnesium, 2 hydrogen, 2 hydrogen, 1 sulfate, 1 sulfate. So this one is also already balanced. To finish up our word equation, we would say that hydrogen and magnesium sulfate are our products. Okay, I'm going to skip to reaction 6. This will be the last example I'll go through. So here we have sodium, which we should know is a +1 charge. Here we have iron, and based on our periodic table of charges, we can see iron is either 2 or 3. Looking at this formula, we'll see iron is a 3 charge in this instance. The charge of our variable metals will remain throughout the whole equation. So iron will stay a +3 if we're switching things up. It's not all of a sudden going to change to a +2. And then bromine is a -1. So again, looking at our thing that's by itself, we see we have sodium, which is plus. So that means it'll try to replace the other plus thing. Can it happen? We need to reference our chart here. So Na and Fe. Na is more reactive, so it will switch so it can be in the compound instead of iron. That means iron is now alone. Na and Br will be together. I want to make sure that I'm making the correct formula. These both have a 1 charge, so NaBr would be the correct formula here, because even though there was a 3 for bromine in this formula, that came from iron. Now that bromine is not with iron, we cannot put a 3 there because sodium doesn't have a 3. Check to see if iron has part of Hoberfinkel, and it is not, so I just put Fe, and that's all I have. And then last step will be to balance. This one is not already balanced. We can see we have 1 sodium, 1 iron, 1 iron, 3 bromine, 1 bromine. When we balance, we cannot put subscripts. We have to put big numbers in front, coefficients. So if I know that I have 3 bromine here and I want to get 3 bromine here, I need to put a 3 in front. Now, because Na and Br are combined in an ionic compound, this means I will have 3 NAs and 3 Brs. So now I have a balanced number of bromines, but I no longer have a balanced number of sodiums. But I can easily fix that by also putting a 3 in front of sodium. The irons did not change in that process, so they still have 1 of each. To write our name for the products, or to write the word equation, we had sodium by itself with iron, and we said it was iron 3, bromide. And it reacted to form iron by itself with sodium bromide. Okay, you should try to complete the rest of these pages, the rest on pages 9 and 10, and we will go over them together in class.